Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In current lecture, we are solving problem 249. So, in problem 249, O2 at 200 bar is to be stored in a steel vessel at 20 degrees centigrade. It means that initial pressure P1 is equal to 200 bar and initial temperature T1 is equal to 20 degrees centigrade, and convert this degree centigrade into Kelvin because we will use ideal gas equation, and in ideal gas equation we use Kelvin, not use degree centigrade. So if we convert degree centigrade to Kelvin, add 273 to 20 degrees centigrade. So the new value will be in Kelvin, 293 Kelvin. The capacity of the vessel is 0.04 cubic meter. V1 is equal to 0.04 cubic meter. Assuming that O2 is a perfect gas, it means that we will use perfect gas equation. Calculate the mass of O2 that can be stored in the vessel. Calculate mass. The vessel is protected against excessive pressure by a fusible plug, which will melt if the temperature rises too high. At what temperature must a plug melt to limit the pressure in the vessel? At what temperature? It means a point temperature. Point temperature at which the plug melt to limit the pressure in the vessel to 240 bar. This is P2. P2 is 240 bar. The molar mass of oxygen is 32 kilogram per kilomole. So we can easily find T2 from equation P1 V1 divided by T1 is equal to P2 V2 divided by T2. So cross multiply this equation. So P1 V1 T2 is equal to P2 V2 T1. So this implies that T2 is equal to P2 V2 T1 divided by P1 P1, which is equal to, the value of P2 is 240 bar. The value of V2 is, volume is constant because here is the to a steel vessel at 20. The capacity of the vessel is 0.04. Because we cannot change the capacity of the vessel, so V1 is equal to V2. V1 is equal to V2 is equal to V. So volume is constant, 0.04 cubic meter. T1 is 293 degrees centigrade divided by P1. The value of P1 is given to 200 bar, and the value V1 is constant, 0.04 cubic meter. So bar will be cancelled with bar. 0.04 cubic meter will be cancelled with this, and this is not degree centigrade but this is Kelvin. This is Kelvin. So T2 will be equal to 351.6 Kelvin. 351.6 Kelvin. If we find this value in degree centigrade, so subtract 223 from this value. So T2 is equal to 351.6 minus 273 degree centigrade, which is equal to 78.6 degree centigrade. So this is the value of T2, final temperature. Now find mass. So for mass, first we find R, ideal gas constant. For m, first we find R. As we know that R is equal to molar gas constant divided by molar mass. The value of molar gas constant is 8.314 Newton meter per kilogram per kilomole per Kelvin, and the value of molar mass is given to us is 32 kilogram per kilomole. Kilomole will be cancelled with kilomole, so the value of R will be equal to 0.2598 0.2598 2598. This is kilonewton meter, so kilo Newton meter per kilogram per Kelvin. Now we can easily find M by using formula P1 V1 is equal to MRT1. So this implies that M is equal to P1 V1 divided by RT1. So M is equal to, the value of P1 is 200 bar, and convert bar into Newton per square meter, 10 power 5 Newton per square meter. The value of V1 is 0.04 cubic meter. The value of R is 0.2598 kilo, and we multiply by kilo, this will be 259.8. This will be 259.8 Newton meter per kilogram per Kelvin, and the value of T is 293 Kelvin. So Kelvin will be cancelled with this Kelvin. Newton will be equal to Newton per meter, and per meter square, per meter cube will be cancelled with meter cube. So final unit will be kilogram. This kilogram. So mass is equal to, this is simple calculation. If we calculate this, so mass will be equal to 10.5 kg, and this is the final solution. So for more videos, please like and subscribe my YouTube channel. Thank you.